Hello students, welcome to the course of Automotive Manufacturing Processes and Technology. Myself Vimal Salot from LJ Institute of Engineering and Technology. In this session, I am going to discuss about different types of the pattern allowances, types of patterns and different types of the pattern materials from the casting chapter. So let us start with pattern allowances. We know that pattern is a replica or duplicate of the casting which we want to produce. Now pattern is not made exactly to that size of the casting. Some allowances are allowed to make a pattern. So let us see what are those different allowances and what is the importance of each and every allowance. So first of all, let's see what are the different types of the allowances. Shrinkage allowance, draft allowance, machining allowance, distortion or camber allowance, shake allowance. So these are the different types of the allowances which are necessary to provide on the pattern. First allowance is shrinkage allowance. This allowance is important from the viewpoint of shrinkage of a molten metal. It can be compared with the formation of ice. We know that when ice is formed from the water, its volume decreases. Or in a reverse process, if ice melts, its volume increases. Similar concept can be applied to molten metal. We know that molten metal is allowed to solidify or to cool down for the formation of a casting. So when molten metal is solidified, there will be some decrease in volume. So that decrease in volume can be compensated with the shrinkage allowance. So there are two stages, liquid shrinkage and solid shrinkage. Initially, metal is at pouring temperature. For each and every metal, melting temperature or pouring temperature is different. So initially metal is at melting temperature, and after that it is allowed to cool down, so it will lose some heat and its temperature decreases. That process is a sensible cooling. Now it will arrive at freezing temperature, but still it is in the phase of liquid. Now from liquid to solid, phase transformation takes place. During this stage also it will lose some heat, so it is known as a latent cooling. Phase transformation takes place during this stage. From liquid it will be converted into solid. So up to this stage it is a liquid shrinkage, but at this stage still it is in solid, but it will be at higher temperature as compared to surrounding or room temperature. So further it is allowed to cool down. So when it comes to room temperature, that type of shrinkage is known as a solid shrinkage. Let's see with diagram. Here it is a molten metal, and when it is allowed to solidify, you can see in this diagram how its volume is decreasing. Here you can see it is a decrease in the level. Here also you can see how it is get contracted when it becomes solidified. Now shrinkage allowance, how it can be compensated. So for liquid shrinkage, the required metal can be compensated from the riser portion. In getting system there is a riser through which we can notice that the cavity is fully filled with the molten metal. So here it is a riser portion, it is a liquid metal. So when it is poured inside the cavity, and when this cavity is fully filled, the liquid molten metal will start to come up through this riser. So here this liquid metal is shown by this yellow color. Now during solid shrinkage, when its volume decreases, it will require the molten metal to compensate that decrease. So that metal is supplied from this riser portion. Here in this diagram you can notice that the level of liquid metal is decreased. So up to this much level, the liquid metal is used to compensate the shrinkage. Now for solid shrinkage, it is proportional to alpha, where alpha is coefficient of thermal expansion of metal, but from metal to metal its value may be different. It is specified as mm per meter for each linear dimension. Next allowance is a draft allowance. This diagram shows the pattern without draft. After solidification, it is necessary to remove the pattern from the mold in such a way that it may not damage the mold cavity. So for that easy removal, draft or taper can be provided on the surface. So here you can see it is a pattern with draft. This surface is provided with some slope or taper, so it would be facilitate easy removal of the pattern from the mold cavity. Next allowance is machining allowance. Here it is shown in this diagram, necessity of machining allowance is shown. It is a casting before machining, and in this diagram it shows the casting after machining. In case of casting process, we will not get the final product at the end of the solidification process. Always it will require some machining process to be performed on the casting to get desired shape, size and accurate dimension. In this diagram, these blue color lines are showing the actual dimension of the casting which is required, and the diagram which is shown by this black color shows the dimension or size and shape of the pattern. So here you can see xmm is provided on each and every side. That much extra dimension is provided because when we get the casting, we will require to perform machining operation on all these sides to make it a finished product. So after machining, we will get the required dimension of the casting. It is also specified as xmm per side. Next allowance is distortion allowance or camber allowance. It is shown with example. Two examples are shown here. First diagram shows the required shape of the casting. Second diagram shows distortion of casting, and third diagram shows the cambered pattern. Now what happens in case of a casting is of thin section, then there is a chance to get distorted after the solidification. So to compensate that distortion or cambered portion, always it is allowed to provide some distortion or camber allowance on the pattern material. Another example is also shown here. It is original casting, and in this diagram you can see how it is distorted. As it is a thin section casting, there is a chance of distortion or this diagram shows the cambered part. So opposite direction, the allowance is provided to compensate the distortion. Next allowance is shake allowance. Here in this diagram it is a pattern, it is mold, and with the help of this draw spike we can remove the pattern from the mold, but for that purpose it will require to shake the pattern or to provide some movement so that we can easily remove this pattern from the mold cavity. So for that purpose shake allowance is provided on the. Now let's see different types of the patterns. Different types of the patterns are single piece pattern, split piece pattern, gated pattern, loose piece pattern, follow board pattern, sweep pattern, multi-piece pattern, and skeleton pattern. Now let's see each pattern in detail. First type is a single piece pattern. If casting shape is very simple, then it can be made in a single piece. It is also known as solid pattern. So it is a simplest type of the pattern. It is known as single piece or solid pattern. Next type is split piece pattern. Sometimes pattern can be made in two parts if it is symmetrical. So upper part of the pattern remains in cop and lower part of the pattern remains in drag. Both the parts can be aligned perfectly with the help of this dowel pin. Here you can see these are the dowel pins. These pins are actually one type of projection which is mating with exactly negative impression on this second part. Next type of pattern is a gated pattern. By this type of pattern we can produce multiple casting of same shape and size in a single application. It can be useful if size of the casting is small. One simple example is shown here. So it consists of a runner and gating system for each and every pattern. Through this runner, molten metal will be flowing and it is a gate through which the molten metal will enter inside the mold cavity. All these are the patterns. So all these patterns are attached to a common runner with individual gate. It is known as a gated pattern. Next type of pattern is loose piece pattern. Some components contains projected part. Projected part means extension of the surface. Simple example is shown here. It is a pattern and these two pieces are projected part. So this type of projected part can be made with the help of a loose pieces. These pieces will be made separately. Pattern for these pieces will be made separately and separately it can be molded with the main pattern. Sometimes it becomes difficult to remove the loose pattern from the mold, so it requires skill. Next type of pattern is follow board pattern. When casting is thin in section or it is delicate, then there is a chance of damage to the pattern because of ramming action of the sand. Simple example is shown here. You can see in this diagram it is a pattern and you can notice that it is very delicate and thin in section, and it is a board which is used to support this pattern. It is known as a follow board. So purpose to use follow board is to support the pattern and it also provide a seat for the pattern. So this type of pattern is known as a follow board pattern. Next type of pattern is a sweep pattern. If casting is symmetrical about its vertical axis, then it can be made with the help of a sweep pattern. It consists of a vertical spindle and it is a sweep which is made from the wood. So when sweep is rotated about this vertical spindle, exactly similar cavity can be cut on the other part of the shape. So completely mold cavity can be produced. So this type of pattern is known as a sweep pattern. Next type of pattern is multi-piece pattern. Sometimes casting is made from the more than 1, 2 or 3 pieces. It is known as a multi-piece casting and the pattern is known as a multi-piece pattern. Here this pattern is shown and it is an example of 3-piece casting. So it is upper part, it is lower part and it is a intermediate part. All the parts will be casted separately. For each and every part it will require a separate pattern. So this upper part pattern is rested in the cope, lower part pattern will be resting in a drag part and it is an intermediate part which is resting in a check box. Each and every pattern can be aligned with the help of this dowel pins. Sometimes it is also known as cope and drag pattern. Next type of pattern is a skeleton pattern. If shape of the casting is a simple but size is large, then it can be made with the help of a skeleton pattern. For example, pipes of cast iron. It can be made with the skeleton pattern. So here it is a skeleton pattern and with the help of this trickle board the molding sand can be set in this way. So it will result in a saving of cost. Now let's see different pattern materials and what are the desirable properties for a good pattern material. So properties which is necessary for a good pattern material is it should be light in weight, it should be easily worked, shaped or easily it can be joint, it should be strong, hard and durable for multiple uses, it should be stable dimensionally as it can be used again and again and in all condition it should remain stable in dimensions. It should be easily available and at a low cost. It should be repairable and reusable and we can provide good surface finish to the pattern material. So these are the desirable properties of pattern material. Now let's see what are the different types of the pattern materials. First type and very common type is wood. We know that wood is easily available, any shape can be provided to the wood easily, it retains structure, it is strong also, but drawback is that it absorbs moisture from the atmosphere and sometimes when it loses the moisture to the atmosphere its shape and size may be vary as per the atmospheric condition. Sometimes warpage may also take place. So wood can be used but there are some drawbacks. Next type of material is metal. Metal can be used for machine molding. It doesn't absorb any moisture. It can also be given desired shape and size but it can be made by the help of the wood pattern and that wood pattern is known as a master pattern. Cast iron, brass, aluminum are some examples of metal pattern. Rubbers can also be used to make a pattern. Plasters, that is plaster of Paris, can also be used in some cases as a pattern material. In some casting technique, wax can also be used as a pattern material. Particularly in case of investment casting, wax is used as a pattern material. So these are common pattern materials. Thanks for watching.